Hi everyone, welcome to the standard of ODE. You are given this ODE, y double prime minus 3y prime plus 2y is equal to exponential x sine of x. So this ODE, it is nonlinear and it consists of two parts. First of all, you are going to deal with the nonlinear, with the complementary part, which is yc, which can be reduced as y double prime minus 3y prime plus 2y is equal to 0. So we let our y to be equal to exponential mx, so that now we get our y double prime as equal to m squared exponential mx, and our y single prime as m exponential mx. Then we substitute our value here, so that now we will have m squared minus 3m plus 2 exponential mx, which is equal to 0. We note that exponential mx cannot be equal to 0 in this case, which tells us that now m squared minus 3m plus 2 is the one which is equal to 0. This is a quadratic equation which can be simplified as factorized as m minus 1 into bracket m minus 2, which is equal to 0. In this case here, your m1 is equal to 1 and your m2 is equal to 2. Is equal to 2. Meaning that your y complementary will be equal to c1 exponential x plus c2 exponential 2x. Now our y particular, now you concentrate on your y particular. Our y particular will be equal to exponential x sine of x over f of d, which is equal to exponential x sine of x divided by f of d squared minus 3d plus 2, which is equal to exponential x sine of x divided by, there is some bracket there, f of d plus a, whereby our a is the value there in that exponent. So our yp will be equal to exponential x sine of x over, where you have d, you want, so we will have now d plus 1, then we square that part here minus 3 into bracket d plus 1, then plus 2, which is equal to exponential x sine of x, everything divided by, you square this part, which will give you d squared plus 2d plus 1 minus 3d minus 3 plus 2. So yp is equal to exponential x sine of x divided by, here you have d squared, you have 2d minus 3d, which will give you minus d, then you have 1 and this, which will give you 1 minus 3 will give you minus 2 plus 2 will give you 0, which is equal to exponential x sine of x divided by 1 squared minus d, which is equal to exponential x sine of x divided by minus d minus 1 minus 1, which can be written as exponential x bracket minus d plus 1, close the bracket, sine of x divided by minus d minus 1 multiplying by minus d plus 1. So I have multiplied by minus d plus 1 and I have divided by the same, which does not change our operation. So yp is equal to exponential x into bracket minus cos of x plus sine of x. Here d means we differentiate, so I have differentiated the sine of x with respect to x to get cos here. So then the denominator will be d squared minus 1, which is equal to exponents x minus cos of x plus sine of x. We divide by 1 squared minus that. So our yp is equal to minus 1 over 2 exponential x into bracket minus cos of x plus sine of x. So now we write our solution of our given OD. Our OD was y double prime minus 3y prime plus 2y is equal to exponential x sine of x. So our solution will be y is equal to y complementary plus yp. We substitute our values, which will be equal to c1 exponential x plus c2 exponential 2x minus 1 over 2 exponential x into bracket minus cos of x plus sine of x. We close the bracket. So that is our solution of our given ODE, which is here. So thanks so much for taking your time to study with me on how to solve nonlinear online difference equation of second order. For more such examples, tune on to my channel so that we may continue learning together. Kindly also remember to subscribe to the channel so that you may find all the materials whenever I upload them for us.